Welcome to one more video where we're going to be playing with logarithmic functions and exponential functions. And in front of you, the list of properties I already mentioned in my different video. I also mentioned how logs and exponential functions are inverse to each other, so they undo each other. And also the most important part is to remember the definition, how to jump between logarithmic function and exponential function. Let's review some examples here. Rewrite the given exponential equation as the logarithmic equation. You know, if you already watched my video how I solve logarithmic exponential equations, you know my style. I just like applying ln to the both sides. Simple as that. And then usually that works. So I don't promise it's always the best way to do it, but I notice it works all the time, so why not? ln e cubed equals ln x. And then look at that, ln undoes e, so it will be just 3. If you don't believe me, put 3 down using the properties of logarithms. So it will be 3 ln e, but ln e is 1. So I will have 3 equals ln x, and that's exactly the logarithmic equation. That's what they want me to write down. From the exponential equation, that's exponential equation, to the logarithmic equation. Here it is. What to do with the second one? Well, 7 equals y. How could I write down this as the exponential equation? Well, we can probably just use e. Oh, that's not 7. I'm sorry about that. Logarithmic equation. Rewrite as the exponential equation. Basically, we're doing vice versa here. So from logarithm to exponential. We'll just do the same thing I just did before, but instead of log, apply e to the both sides. We'll have e and e over there, over here and over there. So it will be e to the ln 7 equals e to the y. But e undoes ln, and whatever the input is stays. So it's going to be 7 equals e to the y, 7 equals e to the y. And that's the answer, that's all. So please don't overthink those problems. They're actually that fast and that straightforward. You just need to apply ln if there are exponential functions and e to both sides if there are logarithmic functions. Done. Now, what is happening over here? Here they want you to understand the idea of logarithm or also definition of it. So I always teach it this way, in kind of a funny way. What is logarithm base 6 of 1 over 36? Well, you ask yourself, 6 to what exponent gave me 1 over 36? That's like a nice game or a puzzle. If you don't know this answer, then maybe rewrite 1 over 36 as 1 over 6 squared. What created? So 6 to what exponent, what to what power gave you 1 over 6 squared? You still don't know? Then rewrite 6 to the question mark gave you 6 to the minus 2, because 1 over 6 squared is 6 to the minus 2. Well, now it becomes obvious. Negative 2 made it happen. So the answer is negative 2. You also could just rewrite it in the first place. Logarithm 6 to the negative 2, because that's what 1 over 36 is. That is, basically you take this negative 2 and put it in front of the log. It becomes negative 2. Let's make this exclamation mark smaller. Log 6 and 6, but that's 1. So the answer is negative 2, which is the same thing. So two ways of seeing it, using properties of logarithms or asking yourself a question. What power gave me whatever is inside of the logarithm? So again, 4, so let's look at b. To what power gave me 64? Let's count. 4 times 4 times 4. 16 times 4 is 64. Okay, that's 3. So the answer is 3. Again, it's very fast to do it this way. Or, of course, you can do it the proper way. The proper way will be to write down log base 4, 64, that's 4 cubed. The third power goes down. Log 4 base 4 is 1, so the answer is 3. Same thing, but faster if you actually know what they're asking about. Finally, let's talk about merging logs together and giving the the appropriate completion of this equation. So for the equal sign to be true, something is missing on the right hand side. Let's see what it is. Basically, they ask you to remember the properties of log. Log plus log is a log of product. So it's going to be log base 8 product of 3 times 7. Because logs can be merged into one log if they are added. 3 times 7, that's 21. So the answer is 21. Done. When you have a minus sign like this, then you know it's going to be log of division, base 9. And then whoever goes first goes to the numerator. So it's going to be 8 over. The second one seems like missing, so I'm going to put x over x. But on the right hand side, it says that it should be 8 over 7. So x is 7. What is missing here? 7. Basically, they're checking you remember the properties. Finally, how to get from log base 825 to log 85? Well, log 825 is actually 5 squared, correct? And I mentioned so many times, my favorite property is that this little exponent can jump down in front of the log. So it's going to be 2 log base 8 of 5. So the answer is 2. 2 is in front of the log 8, 5. And that's all. Those are the coolest kind of little games you can do with logs. I always like them because they're fun. I like how the power can jump down, but only if it's inside of the log. I like how the many logs added together can merge into the product inside of the log. Or many subtracted logs can create a fraction inside of the log. This is kind of fun, you know? It's like little games you play with logarithmic and exponential functions. And these things have lots of applications in applied mathematics, in biology, medicine, engineering, and physics. So don't be discouraged if you think that this will never be useful in your career. You never know. Maybe you'll be paid 100 grand per year just for playing with logs. So have fun with them right now and get good grades on the exam. See you next time.